Hello, my name is Dinatra Misha, and I'm going to talk to you about optogenetics and mind control and how it can impact the society of tomorrow. So in this video, we'll talk about what is optogenetics and the various applications that optogenetics has, and that is mapping the neuron pathways, controlling degenerative brain diseases such as Alzheimer's and other forms of dementia, and also mind control. And by understanding these fields, we will be able to evaluate the impact optogenetics will have in future societies. So what is optogenetics? It was founded in 2005, meaning it's a relatively young area of study and allows us to understand the brain at a cellular level. That is, we are able to understand neuron pathways and how they fire. And it also gives us control on firing these neuron pathways, thus enabling us to control the brain. Now, figure 1 shows generally how this occurs. So a synthetic gene is synthesized in a lab and is implanted into an organism through a virus. Now, once this virus settles in the brain, it promotes the production of rhodopsins, otherwise known as opsins, and these are photosensitive molecules that control the firing of neurons depending on the wavelength of light that hits them. Now, the wavelength of light is met through an optrode, a fiber optic cable, plus an electrode that is implanted in the brain of the organism and emits a specific wavelength of light to which the opsin receives and carries out the firing of the neurons. In 2012, scientists were able to map parts of the brain using optogenetics. Now, this was a massive thing because it has allowed us to understand how the neuron pathways work, where they link, how the different parts of the brain read them. And the two ways we're able to do this is through transgenic method and the binary method. Now, figure 2 shows the transgenic method, and figure A in figure 2 shows the conventional transgenic method. B shows the gene trap method, C the BAC transgenic approach, and D the knock-in method. Each of these serve a different purpose once the gene of interest is implanted. The gene of interest, or the opsin, being CHR2 or channel rhodopsin 2. This is the photosensitive gene that is triggered by the wavelength of light. And this figure 3 shows the binary method. So A is the Krelox method and B being the TET inducible method. Now, the difference between transgenic and binary method is that the transgenic method functions through a promoter when the rhodopsin is settled behind the promoter being PA in figure 2, and the binary method functions when the whole thing functions under the control of a driver. The driver being at the very end CHR2, which is generally the rhodopsin. This has allowed us to understand how neurons fire depending on the organism's movement, cognition, and emotions. Now, so far, this has only been done in mice and bacteria. So bacteria show no emotion, I'm guessing. So mice have movement, cognition, and emotions, and we're able to see how different parts of the brain work, how neurons fire differently based on these things. And this has laid the groundwork for future studies in optogenetics, which are when studying degenerative brain diseases. Now, as we can see in figure 4, the low, middle, and high income countries all show an increase, a projected increase of people with suffering from dementia. In low and middle income countries, it's extremely scary because it is increasing exponentially and expected to triple within the next 45 years or so. In high income countries, the increase is still low, but it is still increasing. And for optogenetics to have the cure for this, whereas no other field of study does, it is a huge impact for society. So this was a study done in 2013 where a opsin known as photoactivatable RAC1 was used along with a wavelength of 536 nanometers of visible light. The cytoskeleton that is degenerated through as a result of Alzheimer's has stopped and in fact has reversed, thus regenerating the body. Another field of study that optogenetics has had a lot of progress in is mind manipulation, otherwise known as mind control. Now, no, this is not pseudoscience, this is actually happening today. In 2012, neurologists were able to toggle a rat's eating habits, making it eat when it's not hungry by a simple flick of a light. And at the same time, they were able to activate killer instincts within the mouse or rat. And this can be seen in the video here. When the light is on, the rat feeds. When the light turns off, the mouse lets go of the food and just walks away. Then when the light is triggered again, it eats. Therefore, we can see that this will impact future societies as it will allow us to selectively trigger responses within other organisms on Earth. So you would want a cow to produce more milk? No worries. You want a cow to stand still while you're milking it? That's easy. You want to hunt or slaughter chickens? You can make them stand still. Also, it can also help eating habits. For example, if an anorexic person desperately needs to feed, then we can trigger a response to allow the anorexic person to eat against their own will. So this will impact society, but will be positive or negative. It is hard to tell. Because on one hand, optogenetics offers a solution to brain disorders, eating disorders, psychological disorders, and also helps us understand the brain better so we can help other fields of study along with optogenetics or through optogenetics. And the downsides to it, as unreal as it sounds, it can be used to eliminate certain responses in the human body, such as fear. It can remove free will, making us mindless drones. And if a certain Nobel Prize winner or a student who doesn't receive a HD for this task gets angry, he can send 10,000 frenzied mice or rats to a certain convener. So even though the impact of optogenetics can be positive or negative, the magnitude is undeniable. They will definitely impact the world of tomorrow. This is the reference list. Thank you.